So the charging by induction. So example, we have a metal sphere and I bring a negative charge rod. What will be the net charge on the right hand side? On the right hand side. The resultant or the net charge on the right hand side, it will be positive. The net charge. In exam, you can draw on the surface, that is acceptable. Even you can draw like at the surface or you can draw on the sphere. That is also correct. Both ways are acceptable. And what will be the net charge on the left hand side? The net charge on the left hand side, it will be negative. So when we create a distribution of the charge, and one more thing you have to keep in mind, like if I draw 3 positive charges on my right hand side, I should draw 3 negative charges on the left. Example, if you draw 3 positive and 4 negative, so this is considered as wrong. Why it is considered as wrong? Because overall this metal is neutral. So if overall it is neutral, it means the number of the positive and negative charges should be same. Only the charge rod create a distribution, like separate the charges from each other. And if we have a metal sphere and I bring a positive charge rod on the right hand side, what will be the charge on the right hand side of a metal sphere? So on the right hand side, because electrons experience attraction, so I will draw electrons, and on the left hand side I will draw the positive ions. And if I remove, when the charge rod is removed, both cases, so the moment we remove this charge rod, even for the first one or for the second one, what will happen again? This metal will be, it is neutral. In all the cases, the metal is neutral, but the only thing what happened is the charges distributed. Then again, the charges will be random. So net charge in all the cases remain 0 on this metal sphere. Is it clear? This method is known as charging by induction. But if I want to make permanent charge, the number of the charges on the rod, it's up to you. Like it is not necessary. It's up to you. Even you can make 1 positive, 5 positive. That's not an issue. Like you can draw any number of the charge on this charge rod. But the distribution, when you show a distribution, you should show a uniform distribution, that equal number of positive and negative charges should be there on the metal sphere when you bring the charge rod. But in this case, when I remove the charge rod, again the charges will be random. So this is charge is created or charge is distributed, but this is not the permanent charging. Like it's not having a permanent positive or negative. So if I want a permanent positive or negative on the charge sphere or on the metal sphere, So what I will do, I will use charging or induction by earthing. So what is the charging by induction? What is earthing? Is a metal wire which allow electrons to move through it. So example, we have a charge sphere. Originally it is random, the number of the positive and negative charges. Okay. Then what I did, I bring a negative charge rod. So if I bring a negative charge rod closer to this, what will be the net charge on the right hand side? So the net charge on the right hand side will be positive. Actually, positive charges does not move, but what happened due to the movement of electron, it appeared that all the positive charges on the right hand side and all the negative, most of the negative charges are on the left hand side. Now, what is the earthing? Earthing is a metal wire which allow the electrons to move through it. So what I did, I connect a wire, this red color wire I attached, and we call this as earthing. Now, because of this earthing wire, what happened? Electrons, because metal, this is earthing wire which is made up of metal. Metals are good conductor of charges, they or electricity. What does it mean, good conductor? It means they allow the charges to flow through them. That's why, like example, most of these plugs, the pins of these plugs are made up of metal. Why it is made up of metal? Because we want the charges to flow from the socket to the appliance or the device, so that it is, the pins are always made up of metal. And why the cover is made up of plastic? So that if you are touching, you will touch the plastic part, so plastic is insulator which does not allow the charges to flow through it. So what happened, these electrons are experiencing repulsion. So as these electrons are experiencing repulsion, so what they will do, most of the electron will go out from the metal wire to the earthing wire, or from the metal sphere to the earthing wire. So if most of the electron will go out, now what is the net charge left on this sphere? So what is the charge left on this sphere? Majority of the charges. The majority of the charges left on this sphere when we connect an earthing wire are positive, because most of the electrons leave this. As most of the electron leave this, there are electrons, but majority of them are positive charge. Now, if I want to make it permanently charged, what I should remove first, the earthing wire or the charge rod? So if you want to make it permanent charge, we should remove the earthing wire. That's correct. Why we should remove the earthing wire first? Because what happened, like this example, if someone said we should remove the charge rod first. So the moment you remove the charge rod from here, so there is no charge rod. Now, majority of them are positive. So what they will do, they will attract the electron. So electron will come inside this metal sphere and again it will be neutral. So whenever we want to make it permanently charged, so we should first remove the earthing wire, then the charge rod. Is it clear? This is charging by induction using the earthing wire. So if I want to make it permanently charged, what I should remove first? I should remove the earthing wire first. So moment I remove the earthing wire, when this earthing wire is removed, so now the negative charge cannot return back to the sphere. And then what I will do, I will remove this charge rod. So moment I remove the charge rod, because now positive charges, like charges, even repelling, so there will be the net charge on this sphere will be positive. Is it clear? The charging by induction using the earthing wire. Same way, example, you have a metal sphere. You have a metal sphere which is having a uniform distribution of the charges. What is the mistake in this metal sphere? Can you identify? What is the mistake in this metal sphere? So yeah, this is not a neutral. It is having more negative charges or more electrons. So that's not correct. Originally, this metal sphere is positively charged. Or negatively charged, not positive. Now it is neutral. Now what we are doing, we bring a charge rod here. And this time we are bringing a positive charge rod. So what will be the net charge on the right hand side? The resultant charge on the right hand side? It will be negative. And what is the resultant charge on the left hand side? It will be positive. Now, if you want to make it permanently charged, what I will do, I will connect an earthing wire. Earthing wire is actually a metal wire. So I connect in metal wire, earthing wire. Metal also contain free electron. So what happened? The electrons which are present in the earthing wire will experience attraction from this positive charge and the other positive charge. So these electrons from the earthing wire will move inside. So majority now, the net charge on this sphere. What will be the net charge on this sphere? Why the electron travel? Because you can see there is more positive charge. There is a charge rod which is positive, okay? And there is a charge which create a distribution that is also positive. So there are more positive charges than negative charges. That's why electrons experience attraction from the earthing wire and they will move towards the metal sphere. As these electrons move towards the metal sphere, so what is the resultant charge? What is the resultant charge here? On there will be positive charges because positive cannot move, but the resultant charge will be negative. And if I want to make it permanently charged, what I should remove first, earthing or the charge rod? So we should remove the earthing. The earthing wire must be removed first and then the charge rod. So this is how we can make the object permanently charged. First, the metal sphere having a uniform distribution of the charges, positive and negative. When you bring a charge rod, a positive charge rod, it creates a distribution of the charge within the metal sphere. Right hand side, you have majority of them negative, and on the left hand side, you have majority of them positive. Then what happened? This is a metal wire, earthing wire. So you can see this is a positive charge rod and there is a positive charge on the metal sphere. So there is more positive charge than negative charge. That's why the negative charge or the electrons experience attraction, which are already there in the earthing wire, experience attraction and move towards the sphere. So now the sphere will have more negative than positive. That is why the net charge on this sphere is negative. And if we want to make it permanently charged, we should remove the earthing wire and then the charge rod so that the charge will not flow back to the sphere. Is it clear? This electrostatic induction by earthing. So if you bring negative charge rod, connect in earthing, net charge will be positive. If you bring a positive charge rod, connect in earthing, the net charge will be negative. So you will find very common, like example, even in winter when the weather is dry, you find like when you're touching a metal objects, you're getting like if you're touching a car door or a metal knob, uh, you're getting electric shock. A mild shock is there. So why it is this? Because what happened in a dry weather, as we are moving around, so there is a friction between air and our clothes or our body. So due to the friction, like example, this is a human body. It's not a look like a human body, but it's just a representation. So as a person is walking, air is moving around him. So as the air is moving around him, so there's a friction between the air and the body. So when there's a friction between air and the body, what happened? The actually there's a transfer of the charge. Electron actually travel from air to the human body. So as electron travel from air to human body, the human body will get positive charge and the air, the surrounding air, the human body will get a negative charge and the surrounding air will get a positive charge. Now, when you touch a metal knob, like example, this is a knob which is made up of metal, say door knob or door handle. So moment you touch, like you are in a contact, so what happened? Your body is negatively charged. So moment you touch, metal is a conductor, so this charge start to move, flow. So when this charge start to move or flow, that will give a spark because energy is released, or it will give a electric shock. Is it clear? Like why you get a mild shock when you touch a metal object or a door handle or a door knob. So as we are walking through, there is a air resistance. The air is fine. That's not too high, but still it is sufficient to charge a body. So when our bodies get charged and we touch any metallic object, the charge which is there on our body transfer to the metal. And when there is a charge transfer, it produces a spark or you may get an electric shock. Is it clear, this example? Same way, like example, maybe you have experienced this. You can inflate a balloon. Say this is a balloon. Yes, you can also get a shock from, like, say a blanket is there. When you rub your hand over the surface of this polyester or a blanket, what happened? The electron actually transfer, and then when the electron return, it produce a shock or spark as well. So maybe you have experienced this as well. Like example, you take a balloon and you rub the balloon with your hairs. So when you rub the balloon with hairs, so actually a charge transfer, electron transfer, say, so electron transfer from here to balloon. What will be the charge on the balloon? The net charge. What will be the net or resultant charge on the balloon? Magnetism part we will discuss. So magnet work in a different manner. It's not about induction. The magnet part, how magnets work, how magnets attract or repel, that will be there because this topic is electricity and magnetism. So in magnetism part, I will explain how magnets work. So when there is a transfer of electron, so the balloon will get a negative charge and the hairs will get a positive charge. And then you can all stick this balloon with a wall after rubbing with your hair. Like example, if this is a wall and you place this balloon, so when you place this balloon, that what this balloon will cause, it causes electrostatic induction. What is electrostatic induction? Positive charges on one side and negative charges on other side, and unlike charges attract each other. So this balloon will remain in contact for some time. Once the balloon loses its charge, again it becomes neutral, so it will fall back to the ground. Is it clear? This example, like rubbing your balloon with your hairs, you can also do this as a simple experiment. Take a balloon, rub with your hair for some time, and then bring near to the wall. You will find that the balloon will stick to the wall. So why the balloon will stick to the wall? Because of electrostatic induction. And why the balloon is get charged? Because of electrostatic friction. So two phenomena are happening here. One is the friction, due to heat electron transfer, and another one is induction, that distribution of the charge is created by the help of another charge object. You may also experience, like when you're combing your hair, if you have a long hair, when you're combing your hair, after some time, the hairs are attracted towards the comb. So why it happened like this? Because when you're combing your hair, here most of the combs are made up of plastic, so there's a friction between the comb and the hair, and that friction causes the electron to transfer from one material to another. So when one of the material will get a positive charge, another one get a negative charge, so unlike charges attract each other, so your hairs attracted towards the comb. Is it clear, these examples? More I will give, but this is like everyday example where you experience this electrostatic friction and electrostatic induction. This already we discussed this part. there is a way to identify the nature of a charge that's called gold leaf electroscope. That's a device which is used to find the nature of the charge. So example, you have a cloth and a perfect rod, and now you're rubbing them together. After rubbing, the electron actually jumps from the perfect rod to the cloth. So there are positive charges on the cloth, but most of them are negative. And there are negative charges on the perfect rod, but most of them are positive. This is called electrostatic friction. And another example, you are rubbing a cloth with polythene rod, and you observe that the electron jumps from cloth to polythene. So in this example, cloth will have a net positive and polythene will have net negative charge. And charging by induction, when object, like if I bring a positive charge rod, you can see this is a positive charge rod. So what it create a distribution of the charges, negative charges on one side and positive charges on other side. And if I bring a negative charge rod, so positive charges on one side and negative charges on other. And according to law of electrostatic, if two unlike charges are there, like positive and negative, they will attract each other. And if two like charges are there, they will repel each other. Conductor, the material which allow the charges to flow through them are known as conductor, and all these metals are conductor. So example, if the electron is here, if this electron can move through, they're not moving in a straight line, moving randomly, but if the electrons are able to enter from one end and leave from the other end, what we call this material, we call this material as conductor. But what happened if electron entered from one end but not able to go out from the other end and remain at the surface? So if electron is here, this electron is not able to, it can just stop at the surface, not able to pass through. So what we call that material as insulator. Why some materials are conductor and some are insulator? That is related to the type of the bonding or the structure of the molecule which this material is made up of. So for this, you should understand the concept that all the metals are conductor. They allow the charges to flow through them, where non-metals or composite materials such as plastic, rubber, wood, glass, these are insulators, does not allow the charges to flow through them. Now, what are the dangers of this static electricity? Like how this static electricity can be dangerous? Look, you will find that a lightning or a flash in a thunderstorm. What is the reason for that? Why there's a lightning or the flash in the thunderstorm? As these clouds, like these are the clouds, so these clouds are moving. So as these clouds are moving, so there's a friction between the air and the clouds. And due to this friction, what happens, whenever there's a friction, the chance is there that the charges may transfer. So charges transfer from cloud to air. So the cloud is getting, example, a positive charge, air will get negative. And what happens when too much charge appear on this in air? As the air is too much charge, what will happen? This charge will, because like charges repel, so this charge will move randomly. As this charge will move randomly, that's why what you will see a lightning or a flash. Like when, and lightning and a flash is only observer, you can only observe lightning or a flash when there is a cloudy weather or a thunderstorm. Like too many clouds are there, you can observe in that case. Normally, like if you have a sunny weather or you don't have too many clouds in the sky, you cannot observe this lightning or a flash. This is only observable when dense clouds moving through the air, because of the friction they get charged, and as they get charged, the charges move randomly, and as they move randomly, it will produce a lightning or the flash. So you can see, normally in case of this one, air and cloud, normally positive charge is there on the surface of the cloud and negative is for air. So you can see here, the friction between the air and the cloud will make the air charge, air become negative charge and the cloud become positive charge. And what happened, there is an electrostatic induction. You can see when the air is negatively charged, so the ground will have a distribution. Say this is a ground and this one is a cloud. Due to friction, the air will get charged. Now what happened, this negative charge attract the positive charge. So it creates a distribution of the charge on the surface of the earth, that is electrostatic induction. And unlike charges attract each other, so these charges will move towards the earth and likely they will strike tall buildings or large structures. What is the reason why the lightning or the flash likely to strike a tall building or the large structure? Because what happened, so this is a ground, and due to the friction, the cloud is charged as well as the air. And you have different size of buildings. Which building this lightning likely to strike? Building A, B, C, or D? Likely it will strike the building A. What is the reason likely it will strike building A? Because what happened? The negative charge air cause an induction like earth. So, but the positive charges, it causes the induction. Induction means like create a distribution of the charge. So it create a positive and negative charge. So because it's a tall building and it is closer to the charges, so charges likely will strike the tall building. So likely it will strike this building. But if lightning can strike this building, so it can even damage, this is very high or too many charges, so this can damage the building. So to avoid this, to overcome this, what we do, we connect a lightning conductor. So a lightning conductor, what is a lightning conductor? It's a metal wire which is placed above this tall building at the top of the building. What is the reason? Because metals are conductor. So when this negative charge attracted towards the building, so metals are conductor, so this negative charge will flow through this earthing wire and move inside the earth or a metal wire. So this metal wire is known as lightning conductor. So it reduces the chance that a building may directly hit by the lightning. Even a lightning hit the building, but more likely it will hit the conductor rather than, because building is made up of concrete, steel is also there, but that is for in strengthen or inside. But outside part of the most of the building is concrete. Concrete is not good conductor, so metal is a good conductor. Likely it will hit the metal and reduce. It will reduce the chance that a lightning will hit the building. It increases the chance that it will hit the metal conductor. When this charge will flow through the ground, but the thing is, when you compare the size of the ground and the charge which enter the ground, that is negligible. That is why a person who's there on the ground will not feel this shock, because of the size of the land or the surface of the earth. Is it clear? The lightning or the flash? That is why you will find like the lightning likely to strike the trees. It, you should not, like if it is raining, you should not be under a tree as well, because the lightning likely to strike a structure which is large or a structure which is made up of metal. These are some, actually what are these are the movement of electrons, but too many millions or trillions of electrons are moving, and it is random movement. That's why you do not see a specific position, like a specific direction. It's moving randomly, but more likely it can hit the ground, because when these charges are moving towards the earth, so they're losing their energy. So some of the lightning or a flash, it end in between. Why it end in between? Because the charges which are moving, they're continuously losing energy. So maybe at this point charges lose all of their energy, so not able to move towards the earth, or we are not able to see their complete path. Same way for refueling, normally for it's for aircraft. Airplanes are moving at a very high speed. So when the airplanes are moving at a very high speed, the body of these planes will get a charge. So when these planes are moving at a very high speed, the body will get charged. So when the plane lands, this charge, when there's a charge, this charge can produce a spark, and that spark can cause a fire. Like a fuel can catch fire due to that spark, and that can even burn this whole plane. So to reduce this effect, while refueling, when the plane lands on the ground, so when they're refueling, they connect an earthing wire. What is the purpose of this wire? First, this wire will remove all of the charge from the plane, and when they remove all of the charge from the plane, then they can do refueling or add a fuel. Otherwise, without earthing, if they connect or refuel this plane, there is a charge on the body, and when this charge start to move, it produces a spark, and that spark may cause a fire or explosion. Is it clear? Any doubt related to this part? Tomorrow we'll do questions related to electrostatic. So tomorrow we'll discuss electric fields and do the questions related to electrostatics. These are the lightning conductors you can see at the top of the buildings. High rise skyscrapers, you will find these very common. For small buildings, because less likely the lightning will strike, so they're not placing these light